All right. Okay, today I'm going to talk about the most complex model that we've had so far. And well, since there's no pending assignment, I'll be on Zoom this afternoon at 1 to probably answer any questions that are coming up about the midterm on Monday. For those of you remote, I'm still trying to figure out the logistics of that. I'll have an update on that this afternoon. I'll send an announcement. Yeah, so but it will be, for those of you in person, it'll be in class, paper and pencil, one 8.5 by 11 gouge sheet, and if you need a calculator, that's okay too. So, I mean, if you remember, sort of the math teachers way back saying, "Oh, you're not always going to have a calculator." Take that, Mrs. Gallagher. Okay. Yeah. So that's. So I'm if you noticed on the sample, there was like a little computational thing. So if you need calculator for that, I mean, I'll try not to make it too complex. Anyway, so this is an interesting model. It's actually one from because one of the earliest purely simulation languages, something called SimScript. This was one of the problems that they had, and and solved, of course. And it puts together some of the concepts that we've been talking about so far. So the idea is, well, here, apologies for the eye chart here, but so the idea is that you have this birth, and there's and there are like there's enough room for 2 ships to be unloaded, and each berth has a crane to unload them. But the way that it works is that if there's only one ship, then both of the cranes can work at the same time. But if another ship comes in, then the crane has to kind of switch off. So is that, I mean, basically here, it looks roughly, in an abstract way, something like this. So there's a queue of waiting ships. And, and that's not a non-vacuous type of thing, because if you remember, particularly around the pandemic time, there was just this ridiculous backlog of ships that are kind of sitting there waiting to get unloaded. And okay, but this is, we're not trying to model, the whole gigantic thing. We're just kind of looking at this one particular thing here. So here are some waiting ships, and then here are the 2 berths with the crane. So when this is happening, each of the cranes is unloading at a unit rate. But if there's only one ship there, then both of the cranes can be unloading at the same time. So it's like, kind of how do you capture the fact that you're kind of moving faster? Now, in reality, this isn't a, how should I say, like, for the purposes of the model, we're gonna make some very simplifying assumptions. First, we're going to assume that the cranes can kind of switch instantaneously. Obviously, that's unrealistic, but again, we're taking a first cut at it. That part of it is not what this model's about. What the model is about is the fact that, say, for any ship that's going through, it could conceivably go through a sequence of times where it's being unloaded at a unit rate, and times when it's being unloaded at twice the rate, and then unit rate again, just depending on what else is happening. So let's say, so let's say the first ship that shows up, well, it's going to get both of the cranes, so it's going to be unloaded at twice the rate. But then another ship shows up, maybe with a smaller cargo, and so one of the cranes switches to that. So now the first ship is being unloaded at a smaller rate. But then let's say the second one finishes and it goes off, and now the first one is back to twice as much. So, do you see the modeling challenge here? So it's like when that first ship shows up, you say, okay, well, it gets both cranes, it works at twice the rate, and so for a given amount of unloading time, since we're working at twice the rate in an event world, we're going to schedule the finish unloading at this. But then when the second ship shows up, then all of a sudden that's not valid anymore. And the thing is, the model doesn't really know until that second ship shows up that's going to happen. And then maybe that second ship leaves, and then we go back to 2. So then, so this is in terms of the event graph issues, we need to be scheduling and then canceling events and making it all kind of work out. Okay, so it's clear what the problem is. All right. Okay, so let's start modeling this. And oh crap, no, that's right. Okay, so we have our in a similar manner as what we were doing with the machine stuff yesterday. So our ship is going to have a certain amount of unloading time it's going to need. And so we're going to, in a similar way as we had with the jobs in the second model yesterday, it's going to come in, it's going to have a remaining unloading time because we're going to need to keep track of that. We're going to need to kind of update that. Now the trick, we can do it in a similar, maybe if you remember yesterday when the jobs didn't get destroyed, when a machine failed, we credited the job with the work that had been done already. So we took away from its remaining time. And we need to do something similar here, except the issue is that if we had been working at double the rate, then we need to sort of reduce the remaining time by twice as much as of the elapsed time as we had before. Whereas if we've been working at a unit rate, then we would just subtract the elapsed time. Do you see that? So in other words, the rate at which we had been working is an issue. So we're gonna do the work when there's a switch of the crane, but we're going to have to tell it what the rate was. And that also leaves the we're not going to do it here, but this leaves the option open for realizing that, well, if 2 cranes are kind of working at the same time, it isn't really twice the rate because it might be less than that. So, but okay, so and then so the ships we're going to have an arrival process like this. Is an arrival process a reasonable thing? Well, if there's a lot of these ships, then it is. If they're, again, if our ships are ones in which there are only a handful of them, then an arrival process doesn't quite work. But since there is a lot of maritime commercial traffic, we'll start with the arrival process and sort of see where it takes us. And so basically each ship is going to come with its unloading time. And so we needed a generator for that. So we've seen this pattern a bazillion times, so this should be quite familiar. Okay, so now, since the two-ness of the model, that is, there are 2 of these berths and 2 of the cranes, as you'll see, the model is complex as it is, enough as it is. We the number of these things is not going to be a parameter in this particular case. Okay, so what so we don't have any parameters. Basically, everything is everything is just sort of fixed as a result of that. But we have a bunch of states. So we're going to have a queue of waiting ships. Okay, we've done that sort of thing before. But now we want to have, well, I have another set, which is going to be a set of the ships that are currently unloading. So that's going to represent the berths. I'm modeling it as a set here. You think, well, since there are only two of them, why not do it as an array? It turns out to be actually a little bit simpler to do it just as a set. So you'll see why in a little bit. But what are some of the main metrics that we're interested in are like the delay in the queue, the time in the system, as well as the metrics around the busyness of the berths and the waiting time in the queue. And queue waiting time in the situation again is, as evidence in the pandemic, is kind of a non-trivial thing because it impacted supply chains and all kinds of other stuff. Okay. So here's the event graph. Got it? Okay, done. No. Okay, what the heck is going on here? Right. Okay. All right. So let's start with run, as we always do. It's down here, and so basically the main two ones are the queue and the set for the berths, and then the delay and the waiting. We're going to NaN those. As we said, that's actually kind of optional. Because that's I do that just to, mostly for situations which we will do a little bit later in the course where we start doing replications, and that just makes sure that when we finish one replication and move on to the next, the value of our states is where it was at the end of the last replication. So that's why we need to reset every state variable at the beginning. That's hence the reset in the code, or which is represented in the run event, which always gets executed first. Because we don't want the states from the previous replication to be carrying over to this one. And so now for these transient states like delay in queue and time and system, it doesn't really matter as much. But if we are firing the property changes, we need to make sure that we NaN them. Otherwise, we're going to get a value from the previous replication. So just to be on the safe side, that's why I kind of do that. Okay, so we've done that, and then now we have this this plate of spaghetti here. So let's try to twizzle it out. Well, oops. And then these actually should be reversed, by the way. Just we need to stamp the time before we add it. You don't want to stamp it after. I don't know why it did it after. Okay, so the arrival of a ship, we add it to the queue. All right, so that makes sense. Okay, so now what happens? What are the two possibilities? Well, remember we have our this B, that this is for berth. And there are two possibilities. There are really only two possibilities. Either the size of the berth is 0 or the size of the berth is 1. So if the berths the berths are empty, then that means that we're going to get both of the cranes. On the other hand, if there's already a ship in there, then we're only going to get one crane. And so what we're going to need two different events to capture that, because, let's deal with the easy one first. If nobody is in the berth, then we can start unloading with two cranes and have a separate event for that. And so what do we do for that? Well, we remove the ship from the queue, and we stamp its time and then add it to our berth. And then we can get our delay in queue as the elapsed time because we stamped it back at arrival. And now we can schedule the end of unloading of two cranes, and R is, for some reason I called it R, is the unloading time. And because we're working with two cranes, our unloading time is half as much as it was before. Okay, so these top three events, so that should be fair. And then when we finish unloading two cranes, and then here's where we simply remove the one from the berth, and the exact call is going to kind of depend. And then the age of the ship is how much time we've spent in the system. As with yesterday's model, we're going to be doing a lot of time stamping, so the elapsed time is going to be relevant in a different context. Okay, so at least these top three, and if we're kind of writing this from scratch, then this is where I would start. Again, pick off the easy ones. This is an easy set of logic, right? So I'm seeing nodding, so at least you're getting that. So that all right. So now let's go back to our arrival event and see what happens if there's already somebody in the berth. So what's the situation with that? Well, the situation is that the ship that was in the berth had been unloading at the double rate. In other words, that ship had kind of shown up and gone through this sequence. In fact, they're right. This event has been executed, but their end unloading two cranes event has not yet occurred. And what we need to do is we need to switch to one crane for these, and then make sure everything is arranged. So let's sort of see what is going on for this. So here, what we're doing, and here this should actually be a call to the work at this is using kind of ancient terminology, peak, pop, po, the actual terms are going to be a little bit different, but we don't want to remove it. We want to, okay, who is that ship that's in the berth? And we're going to credit its work at double the rate, because that ship that was in there had been unloading at twice the rate. And so it's here, I've kind of unpacked the thing, but in other words, internally, we're going to credit the work with twice the elapsed time. And now, when debugging this model, there are a lot of things that can kind of go off a little bit, because one of the things that can go off, if you're not careful, this could maybe drive the elapsed time negative. When things aren't going exactly right, then that's kind of what happens. However, when you do it exactly right, then there's no problem. Why? Because we had been actually kind of working at twice the rate here. Okay, so now what needs to happen? Well, first we need to cancel this end unloading of 2 cranes event, because that ship that was in the berth had previously scheduled it. We need to make sure that that's not there anymore. So it's just a canceling edge. Since this event has no arguments, then we don't need to pass any on the canceling edge. But this canceling edge right here says, okay, since we're now switching to 1, we've credited the work, we're canceling the one that we had scheduled, and now we need to do 2 things. We need to reschedule the unloading time for that ship that was in there, and we need to schedule the unloading event for the one that just showed up. So we need to do those 2 things. So, and because they're a little different, in order to resume unloading with the 1 crane, and I need to know which ship it's on. And so I'm going to schedule that, and I'm going to now that ship is still in the berths, and so I'm going to stamp its time, but I need to sort of depending on the let's see, depending on what I'm yeah, actually, since it's the only one in the set, I can stamp its time without a problem. And so now I can schedule an end unloading with 1 crane, but I need to pass it which ship it is, and the delay is now just the basic service time instead of half the service time here. So I'm scheduling that, passing the ship, because when I finish unloading with 1 crane, I need to know which ship it is. Whereas when I'm unloading with 2 cranes, I don't need to know what ship it is, because the only way that's happening is if there's only 1 ship in the berth. So I don't need to pass it. Okay, so then now, so that takes care of the ship that was in the berth. For the what about the other one? Well, I need to start unloading its. And so now this S, I'm going to remove, let's say remove first, actually. So I'm going to basically pop the ship off the queue. And this is a different ship than the one that was here, even though the letter's the same. It gets an elapsed time. I'm going to stamp its time and add it to the berth. And then I'm going to schedule its unloading, passing it with with the same basic unloading time that's remaining, that's left. And for this ship, this is the original one. For the ship that was in the berth, it's the one after having been credited. Okay. So we've taken care of these, and now we need to see what happens when we finish unloading 1 crane. Well, first we need to remove it, and its time in the system is its age, just as before. But now, what are the possibilities? Well, there are 2 possibilities. One is that let's look at the easy one. The easy one is if there are still ships in the queue, then they just need to come in. So so there's that. Now, on the other hand, what if okay, so this is kind of what if there's no ships in the queue? This is redundant because I know if I finish unloading with 1 crane, then there has to be, after I've removed it, the size of the berth has to be 1, so I don't need that. But if there is nobody in the queue, Now the ship that's remaining gets 2 cranes. So I'm going to have another event that says switch to 2 cranes. I'm going to sort of peek at which ship it is. I'm going to instead call the work thing. But I expanded here just to make sure that it's kind of clear what's going on with that. So I've now credited the remaining ship in the berth with having worked at a unit rate for a certain amount of time, but is not yet finished. And then I want to stamp the time again, because the reason we keep stamping the time is because I need to keep track of when did you start doing this? That's what the stamp time does, because that gives the ship, the elapsed time is then going to be the time from that. And so now, since I'm switched to 2 cranes, I can now schedule an end unloading at half the time or twice the rate. Now, the other thing about that is that ship, though, okay, I had, this is potentially confusing here. When this event occurs, there is always going to be another end unloading with that ship that's left there. You know, in other words, when this event, right before this event occurs, there are going to be 2 of them, 1 for each ship. And the ship that just finished, the other one is still there. So I need to cancel it. And here, this belongs on the edge. So now, when I switch, I need to make sure I don't finish at the other time. So I cancel passing the ship, because this event needs to know which ship it is. But at that point, I'm now working at twice the thing. Okay. And then if a ship shows up in the meantime, then I got to go through this whole process here. Okay, so now, does this make sense? Yeah.
Even if a higher priority to in the event that start more than 1 train happens after the developer happens first. That's to
the well, this event knows which one is which. That's a good, yes. In other words, you want to make sure this will, very good point. You want to make sure this one happens before this. Absolutely. Okay, so now what does that look like? All right, so now in the remaining time, I'm going to start implementing this. And what I want you to pay attention to is kind of how I'm doing it step at a time, because that's an important piece of things. I mean, what I've noticed is that many of your tendencies is exactly the same as mine, which is to kind of put it all in there and then see if, basically see if it works. And for some of you, that's, some of you are much better programmers than I am, and that works for you. But for those of you who aren't, you really want to take it 1 step at a time and make sure that nothing, how should I say, it's like in the last assignment, I mean, there were some who were collecting statistics when the basic model wasn't completely verified. So you want to, how does the saying go? Trust but verify. So don't trust. Absolutely verify. So, all right. So I just want you to pay attention to how I'm doing this, because and all right. So the first thing is our ship. Let's do our ship.
Hey, sir, if you're sharing your screen, we don't see it.
Okay, if I'm sharing my screen, you're not seeing it. I'm not sharing your screen, which is why you're not seeing it. Thank you.
Appreciate it.
Yeah, appreciate, yeah. And I appreciate your bearing with me in this hybrid mode. I mean, I've done remote classes, like actually back in the pandemic, all this was online, but everything, it's like I'm doing that. But the thing with hybrid mode, I got people here in the room, and I got, so it's like when I'm in the room, I'm used to just kind of doing that. So again, I appreciate your bearing with me. So I've just created a separate package for this. I'm calling it Birth, and we want to. So this, our ship, our superclass is going to be Entity, for which there are a million of these. I'm going to make sure I get this, the SimKit one. And now with the entities, unlike the event graphs are basically mathematical constructs. And so the variables on those are like single, double letters, whatever. Oops. But for programming, you don't want to do that. You want to have so, and for here, yeah, I'm going to be unsafe. Now, the thing with these entities is that I also, if I leave it alone, it'll just call itself entity, but these are ships. I want to call them ships. And then for this now, I don't want to, I'm not resetting them. I do want it to be private. And so, but I do need to be getting those. I don't want to have a setter. What I want to have is I'm going to want to work at a certain rate. And when I do that, okay, so the work was, if I'm crediting the work at a given rate, then I'm subtracting the remaining unloading times by the rate times the elapsed time. Okay, so the idea is that when I started, I stamped the time. And so the elapsed time is the time I was working at that rate. And it's the responsibility of the event to do that correctly. So now the second thing is, so if we're doing entity arrival things, first create the entity if you need it. And as far as the arrivals go, what we need is I'm doing this in Java. I will what I will do is I will create a video and do it in Python, showing exactly the same processes. But I need to pick one, and so All right, so the rule for subclassing a SimKit or DeskPy component is that the first set of arguments are the parameters for the superclass. And then the remaining arguments are the parameters for the subclass. And then, don't forget the zero argument constructor, which we may or may not use this time. But we need to call the super with the parameters. And then now parameters, they get a setter and a getter. This does not apply to the Python ones, but sure, private. Parameters are private with setters and getters in the Java case. In the in Python, we don't worry about that. Now, in this case, we've seen this pattern many times. So for when we're having an arrival process subclass, we, like in this case, we're passing a value to we create a new entity. And then, well, I'll tell you what, I'm going to call this ship arrival, because that's going to work better in the Python case, and it doesn't do any harm here. So now, just is it clear why the delay on this is 0? Okay, so that maybe initially there was some confusion about that. All right, so now the thing is that actually I probably should have done it before there, but I'm going to at this point, I don't want to take another step until I make sure that that what I've done is going to work. So I need to and the names don't have to be the same. And you may be wondering why we're using the random variate factory. Instead of just using the constructor. And that will be revealed. In the Python version, the random variate itself is also the factory this time, but let's make these uniform from okay. So so I want to instantiate that. Okay, what have I done here? I've instantiated, and the very first thing I want to do is just print that out. Why? Because the first thing that can go wrong is that the parameters don't get in. Okay, in fact, this was not by design, but okay. Now, do you see what would happen if I didn't do this and just kind of went charging ahead? All right, the unloading time generator was null. It wasn't getting in there. Why the hell isn't it? Why is it null? Look, I'm giving it to it. Right? So, and, okay, now one of the, okay, so one of the things that could be happening is maybe I'm giving it a null thing. Okay, let's check that first. So I'll do I'll stop it here, do a debug thing, and let's look at unloading time generator. Unloading time generator is a uniform variate with a min 10, max 15. So it's actually getting in there. Right? So what the heck is going on? Well, let's go and find out. All right. It's doing like an idiot. It's doing exactly what I told it to, which is nothing. Forgot to do that. Okay, that actually, I didn't intend to do that, but it was still, all right. So this but the lesson is to, take one step and then check it. Okay, so I screwed up on this. But if I'd gone charging head, I would have gotten null pointer exceptions. But don't want that. All right, so now, okay, so now I want to make sure that my ships are actually arriving. So I need to run the thing. So this I want to set verbose to true. Well, let's see. Here, like a lot of times this stopping on events, I want to stop on, let's say, stop after 5 arrival events with, okay, those are going to have no, whoops, arrival events. And then all right, so what I'm looking for is I'm looking for arrival events and arrival events with a ship on it. And if I see those, then I'm good. So let's see. Okay, there's an arrival event there. It's scheduling a ship arrival. There's my ship arrival. There's the arrival. There's the next arrival. There's another ship arrival. So, okay, so this piece seems to be working. I'll say seems because there's never 100%. All right. So now we can start on the, I'll call it a berth. Oops, and I want to extend sim entity base. Like one thing that I sometimes forget, I forget to extend this, and I'm kind of going along, and it isn't working. Now I don't have any parameters on here, but what I do have are affected my queue. And it's called the berths. And now for this, notice I have no parameters, so I don't really need anything more. I do need to refactor. Now, I only want the getters. I want to make sure my fields, these are protected. And then let's make these the last method. And then the second thing is that for the sets, I want to return a copy. Now Just one thing to check is that sometimes when you do the refactor business, it'll replace the basic variable with the getter for that, and you just, that doesn't work at all. So now the first thing you do is do the reset. And then in this particular case, okay, we always call the super on reset. So for this, yeah, in this case, now there are a couple ways of doing this. Well, my preferred way is to do it in the default the zero argument constructor if possible. And that way we can just kind of clear them. Now, if we don't do that, we can instantiate them here, but I'm trying to be green. In other words, reuse our objects. And then in this case, since we don't have any array state variables, we don't need to do the init business, but we do need to fire our property change for the queue. And the convention on these is that the new value always uses the getter method. It's a convention. It's not strictly necessary, but it's something that I recommend. Oops, I don't want the index. I want just the property. And then if we're doing this for the delay, just to make sure this is optional. Okay, so all right, so now I want to see that that is working. So right. Now there's actually since there are no parameters, I don't really need to worry about that. But what I do want to see is I do want to make sure that the property changes are being fired. So let's property change, and this would be a state change listener for the Python ones. So this should be enough to see what I'm looking for is that run method for the birth. Okay, so there it is. And then I see that the queue, the verse, okay, all that's happening. So don't want to go forward until make sure that that's working. Now, I have 1 minute to do the arrival thing. And it's let me, I'm going to call this ship arrival just to make it. All right. So now just as before, I want to stamp the time and then no, for the Java ones, we do this old value, new value business. Do the old value, and then the new value. And then. Okay, so I will, since we're right at time, I do want to at least show you this. So if the size is equal to 0, I'm doing this literally. It's correct. Thank you. Frames up. And then if and you could do an else here. And I want to switch to okay, so what I'm doing here, what I want to see is I want to see now there's a sim event listener. Oops, make sure it's defined first. Okay, so what I'm looking for is I'm looking for that arrival event to schedule those. I know we're a couple minutes over, but I just want to. Okay, what I'm looking for is this ship arrival. Okay, is scheduling a start unloading 2 cranes, which occurs, but nothing else is going on. So, yeah. So now the idea is that if I were to take this event graph, so here's what I did was I've implemented this one and I've tested it for this. I haven't tested it for this. I need to do a little bit more work to test it for this. Actually, so the next thing I would do is implement this event only, because that'll add the guy to the berth, and then the next arrival should schedule this. But that's all I'm going to do for the next step. So the point I'm trying to emphasize here is that even as a model as complex as this, if you do it one event at a time and correct each step as you go, then at the end, you're going to have a model that works, guaranteed. Okay, so again, at 1 o'clock, I will be on Zoom to answer any questions. Again, there are no pending assignments, midterm on Monday. Any further questions about that? You can either ask me this afternoon or shoot me an email, and I will see you then. For those online, I'll send you an email about the logistics, so we'll figure that out. Okay, any questions from the online folk? Yeah, and there's a handout. There's a handout in the handouts one. There's that gives the topics. Yeah.